In this video we are going to learn how we can convert arithmetical expression written in InFix notation to a PostFix notation using an algorithm step by step. This method is very useful on computing to evaluate arithmetical expression without the need of parentheses and respecting the operator precedence. There are rules that we have to follow if we want to convert an InFix notation to a PostFix notation. Let's go to see.
First, operands, meaning numbers or variables, are added directly to the result with any change. Left parentheses are pushed onto the stack as they indicate the beginning of a sub-expression that needs to be processed later. When we found a right parenthesis, we pop out the operators from the stack until we reach the corresponding left parenthesis. Operators are handled according to their precedence. Operators with higher precedence, like multiplication and division, are processed first, while operators with lower precedence, like addition and subtraction, are handled afterward. Finally, after processing the entered expression, any remaining operators in the stack are popped and added to the result. Stop there. Before we start with the step-by-step of the InFix to PostFix conversion method, it's important to understand that the expression is processed character by character, and each one follows a specific flow within the method according to its type. So for this, we have to use a method of the character class, which will allow us to take each character of the expression. We are going to do this like this. Taking into account the above mentioned, we start the process, through which we are going to flow with the help of the diagram that we can observe. First character. The operand 6 is added to the result because the operands go directly to the output. Nothing is added to the stack yet. Second character and second iterator. The plus is stacked because it's an operator. Note the stack has one element, third char. As we saw earlier, the operands are added directly to the result, so the 4 will be added to the result and in the stack the plus follows. Fourth character. The division operator is stacked because it has higher precedence than the plus, and the stack now has 2 elements. Fifth character. An operator again. 24 is added directly to the result and the stack is unchanged. Sixth chart. The division operator is debugged because the multiplication operator has the same precedence, and this is then stacked. Now the stack has changed by 1 element. Seventh chart. We see a new element. The left parenthesis is temporarily stacked and we will see what it will cause later. The stack will remain the same. Right chart. Again an operator, to the results it goes. 9th character. We have an operator and this will be stacked since it is inside the parenthesis. 10th character. We already know. 5 directly to the result. 11th character. Since the plus operator has lower precedence than the division operator, the letter is unstacked and added to the result, and the plus is stacked. 12th character. One more operand to the result it goes. 3rd character. Right parenthesis. This is going to cause all operators on the stack to be unstacked until the left parenthesis is encountered. 14th character. Lastly, we have the less operator. This will cause the plus and the multiplication operators to be unstacked. Then, this itself will be stacked. 50th chart. And we have another operator that will go straight to the result. Finally, we are out of the loop and the expression is partially converted, but we have to check if there are any elements left in the stack. And as we can see, the stack has the less operator that will have to be stacked to add it to the final answer. In this way, we have followed step by step how an InFix expression is processed until it is converted to PostFix. Throughout the process, we saw how would operators are added to the result, and how the operators are parentheses affected to the flow within the stack.